My name is Thomas Diem, and in this video I will be going over question 1 of the FRQ section of the 2014 Calculus AP test. This question consists of 4 parts and allows the use of a graphing calculator. The question states, grass clippings are placed in a bin where they decompose. For values of t between 0 and 30, the amount of grass clippings remaining in the bin is modeled by the function a of t equals 6.687 times 0.931 to the power of t, where a of t is measured in pounds and t is measured in days. Remember that each FRQ problem should take about 15 minutes, so it is in your best interest to read each question slowly and carefully. The first part of the question asks us to find the average rate of change over the first 30 days. To solve this, we need to find the average rate of change of the function a of t between t equals 0 and t equals 30. We know that we are using this function instead of a derivative or antiderivative of a of t because the units of a of t are pounds and days, and we want to find the change of pounds over the course of 30 days. To find the average change between points a and b, we use the expression f of b minus f of a over b minus a. So to find the average rate of change between t equals 0 and t equals 30, we would use the expression a of 30 minus a of 0 over 30 minus 0. So we can plug in the values 30 and 0 into a of t, and we will get 6.687 times 0.931 to the power of 30 minus 6.687 times 0.931 to the power of 0 all over 30. If we plug this into our calculator, we get the final answer, rounding to the nearest hundredth, of negative 0.197 pounds per day. This part of the problem is worth 1 point for the correct answer with the correct units. In part B, the exam asks us to find a prime of 15 and then interpret the meaning of that value in the context of the problem. We can find a prime of 15 by taking the derivative of the function a of t and finding the value at t equals 15. Remember that the derivative of a to the power of x is a to the power of x times ln of a. So the function a prime of t is equal to 6.687 times ln of 0.931 times 0.931 to the power of t. We can plug in 15 for t and use our calculator to get an answer rounded to the nearest hundredth of negative 0.164. The second part of the problem asks us to relate this value to the context of the problem. Remember that the derivative at a certain value is equal to the instantaneous slope at that value. So a prime of 15 is the slope of the graph a of t at the value t equals 15, or 15 days. Since a of t is the amount of clippings in the bin, this means that a prime of t is the rate at which the amount of grass clippings is changing at 15 days. It would be measured in pounds per day. Part B is worth 2 points, 1 for the correct value and 1 for the correct interpretation of that value. Part C of the FRQ states, find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval of 0 to 30. To solve this problem, we first need to find the value of the average amount of clippings. And then we need to find the time t where the amount of clippings is equal to this value. It may be normal to think that we use the function a of t to find the average value. However, we are trying to find the average amount of clippings and not the average rate of change. Since a of t is a rate function and we need a position function, we will use the antiderivative of a of t. To find this value, we use the expression 1 over 30 times the integral of from 30 to 0 of a of t dt. We plug this value into a graphing calculator and get a value of about 2.752635. Remember that since a graphing calculator is permitted There is no need to solve this integral by hand. However, this is not our final answer. This value is the average y value on the interval of 0 to 30, but the question asks for the time t at which this value occurs. We can find the t value by setting this equation equal to the value we found. We can simplify this, and now we can use logarithms to solve the equation for t. We can plug this into our calculator and we get a final answer of t equals about 12.415 days. In this part, test takers receive 1 point for setting up the expression 1 over 30 times the integral from 30 to 0 of a of t dt, and 1 point for evaluating the expression correctly. The fourth and final part of this question states that for values of t greater than 30, the amount of clippings is modeled by the function L of t, which is the linear approximation of a at t equals 30. It then asks us to find the value of t where there will be 0.5 pounds of grass clippings. First, we need to find the equation for L of t. We can do this by finding the tangent line to a of t at t equals 30. The slope of the tangent line is equal to a prime of 30, or the instantaneous slope at t equals 30. We have already figured out from part B that a prime of t is equal to 6.687 times ln of 0.931 times 0.931 to the power of t. To find a prime of 30, we plug in 30 for t. Using a calculator, the slope of the tangent line is about negative 0.055976. Now that we have found the slope of L of t, we can find the equation by using point-slope formula. We can substitute values for each variable. y1 is the y value at t equals 30 on the graph of a of t. M is the slope, which is the value we just found. And x1 is the x value for the point, which is 30. We can now calculate y1 and simplify the right-hand side by distributing. We can simplify more and we get y equals negative 0.055976x plus 2.462214. Or L of t equals negative 0.055976t plus 2.462214. However, in order to solve the problem, we need to find the value of t so that the expression equals 0.5. We do this by setting the expression equal to 0.5 and solving for t. Now we can simplify. And now we can solve for t. We get a final answer of t equals about 35.054 days. In this problem, test takers receive 2 points for the correct equation of L of t, 1 point for setting L of t equal to 0.5, and 1 point for getting the correct answer.